5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
This is About Space, America's return to space, with news and information on our U.S. space program. Is your host of About Space, David Denault.
Welcome, and thanks for joining me today. Now, if you've been following our investigation into time travel, we have learned about the life and achievements of Albert Einstein and learned about how the Alcubierre drive functions. Rather than exceeding the speed of light within a local frame, a spacecraft would travel distances by contracting space in front of it and expanding space behind it, resulting in effective faster-than-light travel. Objects cannot accelerate to the speed of light within normal spacetime. Instead, the Alcubierre drive shifts space around an object so that the object would arrive at its destination more quickly than light, without breaking any physical laws. We'll talk with a modern-day astronomer to hear his thoughts on the possibility of time travel, next on About Space Today. Hey moms and dads, it's the good old summertime, a time to come to the beach. Cocoa Beach, just minutes from the Kennedy Space Center. Stay any Thursday, Friday, and Saturday nights for just $215 per person. That's $215 for 4 days and 3 nights at the Best Western, directly on the ocean and walking distance to the pier, including our buffet breakfast daily and 2 tickets to the Kennedy Space Center complex. This is a D&D Cruise and Tours exclusive promotion for About Space Today by calling 877-747-8631. That's 877-747-8631. This is a limited time promotion, so book early and come on down to see the Space Coast. Welcome back. Derek Demeter is not only a modern-day astronomer, he is also the director of the Emil Buehler Planetarium on the campus of Seminole State College in Sanford, Florida. There's a lot of discussion right now about time travel. We can travel, I think, within our little solar system, can't we?
Yeah, interplanetary travel in our solar system is fairly easy comparatively to other things. We've pretty much covered the majority of our solar system when it comes to interplanetary travel with robotic, unhuman spacecraft. When it comes to interstellar travel, that's where it gets a little bit more complicated. But yeah, I mean, from here to Mars, with our modest technology today, it takes 9 months. Yeah. That seems like a long time, but when it comes to years and years and years of travel, comparably to other places, it's a lot quicker. But the further you get out in our solar system, the longer it will take. So if we develop near speed of light traveling even to the edges of our solar system will actually be fairly quick. We're talking only an hour or two of travel, and so you don't really have to deal with the relativistic issues that you deal with when you start traveling further out.
What about the Alcubierre drive or Alcubierre warp drive in metrics?
From my understanding, the warp engine will kind of cheat relativity, because basically if you can warp using a very intense gravity field around you to where you can warp space-time so much that essentially in a way you can kind of bring two sources together and kind of cheat that going from one point to the other and having this time delay. It theoretically can work, but developing an engine like that is going to require a lot of technological advancements that we don't have really available today.
So with all of your experience, do you believe it is possible then to warp time?
I mean, that's the thing about science is that, people, if you can go 100 years ago and you tell them, or even 150 years ago, and you tell them, is it possible for us to fly real fast in the sky? And some people will go, well, maybe not. But then here we are today. There are I think human ingenuity is the main drive for our technology. I don't think we're going to see this kind of technology available in our lifetime or even our children or grandchildren's lifetime, but I think that it will be possible. I mean, as I said, that the math checks out, the science checks out. It's just putting together our resources to develop that kind of technology. And I think once we get to a point where we find exoplanets out there, we find sources of need, then I think there'll be more of a desire to build these kind of things, because right now it sounds great, but I think once we, with using James Webb and using other technologies to look for these exoplanetary systems that show, yes, this is a place that is Earth-like, yes, this is habitable, yes, this is this, I think will motivate people to endeavor on those technologies like warp. And I said that the technology is feasible. Developing a gravitational force that could essentially warp space-time around you is, physically possible. It's just, how fast can we develop technology? And if we do, then that would be amazing. And that would be really the true way of conquering long distance space travel.
Derek Demeter, a modern-day astronomer and the director of the Emil Buehler Planetarium on the campus of Seminole State College in Sanford, Florida. Well, join me next Tuesday when we uncover the NASA files and what they've learned about time travel. And be sure to have your family and friends listen each Friday for America in Space with Dawn Meyer from Florida's Space Coast. And follow us on Facebook for space news updates at aboutspace.today. And our Tuesday shout-out goes to our friends across the pond in Ireland, with its many listeners who enjoy our weekly programs. And the top of the day to you. And to all our friends and listeners around the globe and here in the U.S., thank you for listening. I'm David Denault, and this has been About Space Today.